Back at you with some geometry, Chapter 7, Section 2, Properties of Parallelograms. Alright, so parallelogram by definition has two sets of parallel sides. Now, due to this, we can figure a few things out. Like we could say, well, this acts like a transversal on two parallel sides, so I know these two would be consecutive interior angles. And if those two are consecutive interior angles, then these are also consecutive interior angles, and so on. So I can go around and figure out a few things in a parallelogram about it. If I know that this is parallel to this, well then this line right here, if it's parallel to that one, would have to be the same length, okay? So, few things. Theorem 7.3 tells me that opposite sides in a parallelogram are congruent. And Theorem 7.4, opposite angles are also congruent. Okay, so super easy. Problem like this, I have 65 degrees here and y degrees there. We need to find x and y. So let's start with super easy, because finding y is equal to 65 degrees, because opposite angles theorem, right, in a parallelogram. Opposite sides theorem tells me that these two are equal. So x plus 4 is equal to 12. Subtract 4 from each side and x is equal to 8. Easy peasy. Let's move on. Parallelogram consecutive angles theorem, right? So if these are parallel, then I know that these are consecutive interior angles. Like on a transversal, they have to be supplementary. So x and y are supplementary, and x and y, right, are thus the same. Okay, and the diagonals, now here's a cool one that might not be quite as obvious, is that the diagonals bisect each other. That means this section to the midpoint is the same as from the other vertex to the midpoint. Very cool stuff here. Alright, so here we have a desk lamp, and this part is a parallelogram. That means however this moves, this angle is going to move too. That's how they keep this steady, right? So the angles of the parallelogram change as the lamp is raised and lowered. Find angle BCD, that's this angle right here, when angle ADC, this one, is 110 degrees. So those two angles to each other are consecutive, and consecutive angles are supplementary. That means they add up to 180. So the measure of angle C is equal to 180 minus 110. And therefore the measure of angle, let's write it the way they did, BCD, angle BCD is equal to 70 degrees. That was easy, lots of fun. Let's keep going. Alright, writing a proof. Here we go. I know you love writing proofs. So, given that A, B, C, D, and G, D, E, F are parallelograms, prove that angle B, that's this angle right up here, angle B must be congruent to angle F. Okay, how are we going to prove that? Well, it's very simple here. We know in a parallelogram, and they are parallelograms, so that's what's given. This is what we're going to do. We know that opposite angles are congruent. So we know that this one is congruent to that one, and we know that this one is congruent to this one. And these two are vertical angles, so these have to be the same, and therefore this. Alright? So all we have to do is write that down. Pretty easy. We were given that those are parallelograms. Okay? And we know that CDA, this angle, is congruent to B, as we just stated, because parallelogram, right? Opposite angles are congruent. And then vertical angles are congruent. And therefore, boom, transitive property tells me that B is congruent to F. So I know you don't like writing proofs, but it's pretty simple. Just you follow logically the steps from B to F and just write down what it is that you're doing. Alright, using parallelograms in the coordinate plane. Find the coordinates of the intersection of the diagonals of parallelogram LMNO with vertices L at 1,4, M at 7,4, N at 6,0, and O at, this is always very nice when we have the origin. Okay, first thing I would do is graph this. Okay, so if you graph it, this is what we're looking at. Okay, so now what we need is we need to find the midpoint between two of the vertices. Now, not just any two, but two opposite vertices. I couldn't find the midpoint between M and N. That wouldn't help me. I need to find the midpoint between L and M, N, or O and M. Okay, so I'll pick M and O because O is the origin. That gives me 0, 0, and that's always fun to work with. So I need M as the other one. Midpoint says I add the x values and divide by 2. 7 plus 0 gives me the x values. And then y values 4 plus 0 divided by 2. And that is my midpoint. Now simplify this. I get 7 over 2. Or 3.5, and 4 over 2 is 2. So 3.5 and 2, yep, there it is. Boom. It's that easy, gentlemen and ladies. Let's see. Here we have 3 vertices, and we are to find the 4th. Now notice that these are always in order, W, X, Y, Z. So if I have a parallelogram, if I have W here, X, Y, and Z, like this, I go from W to X is the same as going from Z to Y because these two are parallel, right? And I'm trying to find Y, so I'm going to see what do I have to do to W to get to X. I'm going to do the same thing to Z to get to Y. So from Z to get to Y, let's see, let's put Y here. Y are going to be my coordinates. X and Y. Okay, so from the X value, I had to subtract 2 from -1 to -3. So I have to subtract 2 from 4. That puts me at 2. And then from the Y's, from -3 to get to 2, I have to add 5. So from -4 to get to this Y, I add 5, and that puts me at 1. So Y is 2 and 1. Pretty easy. The other thing that you could do is you could graph this. Okay, if you graph it, you graph the different points and say, okay, here's W, there's X. I need a parallel line to this, so I'm going to have to go travel the same distance. So I go up 5, left 2. So from this point, I'd have to go up 5 and left 2, and there is Y. And that, ladies and gentlemen, is all we have for today. We've had lots of fun. Check in again next time for another fun lesson.